To learn more about earning college credits with Study Hall courses, visit gostudyhall.com or click the link in the description. In programming and in life, it pays to work smarter, not harder, especially when we're taking on something big, like a team project, which can be, well, a lot. Here's a pro tip I've picked up from all the ones I've worked on. Delegation is key. Sure, it's not earth-shattering advice, but delegation is one of those life skills that shows up everywhere. Life is kind of like one big group project, and when everyone on a team has defined responsibilities and tasks, the work goes more smoothly. It's a life lesson computers can learn too. Or at least we can learn it and then use it with computers. By combining computers and delegation, we can tackle big problems efficiently. And while we're on cliches, there's one that says the best way to eat an elephant is one bite at a time. In our case, that means that the best way to get a computer to complete a task isn't with megabytes, but rather little lines of code with specific jobs that can make short work of a huge problem. Hi, I'm Sabrina Cruz, and this is Study Hall, Code and Programming for Beginners. A program can get really gnarly, really quickly, especially if we want it to do a lot of things. And that can take a lot of time to write and a lot of time to run. But some problems just need something to be done over and over again. And if we can notice that, we can tap into something a little sneaky. A powerful way to reduce redundancy in programming is by using methods. A method is a named block of code that completes a task and that we can call back to throughout the program. To get a sense for how methods work, let's say that I have a craving for some lasagna, because I always have a craving for some lasagna. So I pull out my two favorite kitchen tools, my rolling pin and a chef's knife. With my rolling pin, I flatten the dough into one long sheet. And then with my knife, I painstakingly slice the sheet into glorious lasagna noodles. Both tools did just one job, but together they create a wonderful pile of noodles. And I could reuse them to make lasagna noodles again, or linguine, or ravioli, or... Is it just me? Or should we have Italian for lunch? You're nodding. I'm holding you to it. Okay. We've already ordered lunch. Sorry, back to programming. Methods are like the code version of my rolling pin and chef's knife. They often come pre-built and have specific purposes, and we can reuse them over and over and over. That means less code for us to write, which again, work smarter, not harder. Many methods are already included in a programming language's library, and they're easy to call upon. Like, let's say we're writing a program that's keeping track of how many people have volunteered to help out with specific events. At some point, we want the program to tell us which event has more volunteers. Let's assume we already had code setting up the program. Then in Java, we can call the method math.max, which is already made to take two numbers and return which one is bigger. Let's break up the syntax. The math dot portion of the method lets the computer know that we want to use something from the Java math library. The max with parentheses tells the computer exactly which method we want to use, like picking a specific book out of the library. Then inside the parentheses, we'd put the variables we want the method to consider when doing its work, which we call the parameters. Parameters are like placeholders for the actual values the program will pull later. And we could put this whole thing inside code that tells the computer to print the answer so that we can see it. There are plenty of other methods in the Java library, each performing a specific task. And with all of these methods at our disposal, it's like we're in Samin Nosrat's kitchen with all of these chef's tools. But sometimes the tools we need are really specific, so we can't reuse something that already exists. Methods are still helpful though, because we want to avoid writing repetitive or redundant code in the future. Basically, if you're writing a program and realize that you're writing code to perform the same kind of instructions over and over again, it's time to write a method. That's what Reina does to help her plan events for Scene, a nonprofit organization that serves the unhoused community with the help of hardworking volunteers. There are 2 volunteer opportunities each week: Share a Meal Mondays, which needs 15 volunteers, and Open Closet, a clothing distribution event that needs 20 volunteers. So Reina wants a program that prints out an alert if either event doesn't have enough volunteers. Instead of writing code that performs the same function for each event, she can write a method that does the job for both events. events. To write this method, Reina first needs to do a little setup. She begins by declaring or creating a method with an access modifier. An access modifier specifies whether other parts of the program can access or modify that snippet of code or not. So the public access modifier tells the computer that the method can be used by all the other chunks of code in our program. If we wanted certain parts of the program to be able to use the method, we could put other access modifiers like protected. Then the next word in our code, static, modifies the way a method behaves. Static methods can only directly call other methods that are also marked static. Next, there's the return type, which tells the computer what type of data the output will be, like int or double. Not all methods are going to spit out a number at the end, so in that case, the return type is called void, and that's what Reina uses since she wants her program to spit out a message. Now comes the fun part, which is naming the method. We want to make sure that the method's name makes it clear exactly what the method does. Reina named this method check volunteers because when we call it, we want it to check the number of volunteers for a certain event. Then the name of the method is followed by the list of parameters in parentheses, just like when we use the method that already exists in the Java library. Then, because we're building the method ourselves, we get to decide what it does with the parameters when the method is called. Here we can use an if statement, so the check volunteers method will print a message about whether or not the event needs more volunteers based on the signups on the website. That's all the setup for our new method. Then, before we actually call the method and use it in our program, we can include some other code that takes input from the user about what event they're interested in and how many volunteers it needs. And finally, when it comes to calling a method, there isn't a difference between calling one you wrote yourself versus one from the Java library. We just type the method name, followed by the values we'd like to pass through the method in parentheses. These specific values that are passed through the method are called arguments. So let's say that 14 people registered to volunteer for Share a Meal Monday on the Scene website. When the method is called, the inputs are used as the specific arguments to perform a calculation, and the result is returned to the program where the method was called. Sure, Reina could have just looked at the sign-up list and counted the volunteers herself, but that's not practical as she gets more and more volunteers and events and Scene spreads beyond her community. Now, there's a key thing to be aware of when we're dealing with reusable chunks of code that talk to other chunks of code, like methods. In particular, variables in one part of a program, like a method, can't necessarily be used by other parts of the program, and we'll run into problems if we don't pay attention. In Java, variable scope is how we talk about the parts of a program where a variable can be used. There are several types of variable scope, and for the three we're interested in, we can think of each one like different areas within a college dorm. A variable that has a block scope is like a bed in a dorm room. Just like a bed is only accessible to the students who live in that room, a variable that's defined within the curly braces of a block of code is only accessible to the code within that block. So if we declare a variable pillow within a block of code, then try to use it outside of this block, we get a syntax error when the program is compiling. Next, a variable that has method scope would be like the toaster oven in the shared dorm kitchen. It's accessible to every student who lives on that floor. Similarly, a variable declared within a method can be used anywhere in that method, but not outside of that method. Lastly, a variable that has class scope is like the elevator in the college dorm. Everyone can use it no matter what floor they live on, so a variable with class scope can be used anywhere within the class block where it's declared. Now you may be wondering how we give variables different scopes. Well, it depends on where we declare the variable. We can see variable scope in action when we look at Reina's program from earlier. The variable volunteers has method scope because it's declared in the method. But if Reina tried to use volunteers outside the method, like in a random print statement, she'd get an error message. This might seem annoying and finicky, but understanding variable scope is essential to writing code that uses computer memory efficiently and keeps our programs running smooth and fast. For instance, variables declared within a method are local variables. That means they get created when we call the method, but we let the computer forget about them when the method is finished. But overall, by understanding scope in Java, we can make sure we work with variables in our methods and beyond in ways that get our programs to run correctly. And we make sure we know when and where our variables can be called so that we can avoid running into errors by accessing variables in unintended ways. By using methods and variable scope, we can write lean programs that run reliably, which is really valuable because when we're programming, efficiency is often the name of the game. game. Whether it's a high-budget video game or a smartphone operating system, all sophisticated programs are made up of simpler parts that allow them to run efficiently. That's definitely something we see throughout this course. Problems can feel really big and challenging and totally impossible to program, but computers are powerful tools and a force for good if we know how to work with them and delegate work between different types of code. Methods are certainly part of that, because if we are doing something over and over and over again, there's no point in reinventing the wheel. Yes, I did get really into idioms, by the way. So, by mastering the art of using methods effectively, we're able to build bigger and better programs to solve complex problems. And that makes computers even more valuable tools that can efficiently tackle important work that would be difficult for people to do on their own. If you're enjoying Study Hall Code and Programming for Beginners and are interested in taking an online course and earning college credit, go to gostudyhall.com or click on the button to learn more. Thanks for watching, and see you next time.